Hi, 7th grade. All right, let's get started with Lesson 1, Session 4, Redrawing a Scale Drawing. Okay, let's read the directions. An architect makes a scale drawing of a recreation center. The scale from the actual center to the drawing is 6:1. Ooh, I'm going to highlight that. That's important information. And you know what else I notice? I notice it's a scale factor. Woohoo! Make another scale drawing of the pool using 5:1 as the scale from the recreation center to the drawing. Okay, it's a lot of information here. So let's go ahead and get started. Let me grab my pen. Okay, so here's his drawing. His drawing has the scale factor be for every 6 meters. It's the same thing as 1 centimeter on the drawing, okay? We're going to make a new one that says every 5 meters is to 1 centimeter, okay? So let's go ahead and get started. First of all, we should probably change the original back to like what it is in real life. Do you guys agree with that? Okay, so since the original drawing has 2.5 centimeters is the same as 5 centimeters long, the actual pool would be 15 meters long, wide, and 30 meters long. Okay, so the scale factor from the new drawing to the pool is 5. Let me see here. They really took that and went confusing. So what I think we should do is I think we should just find the actual first and then change it to what they want us to. Okay, so let's do the actual. So remember, if we have a scale factor, which we do, we can just take the number and multiply it to the other sides, which is great. So what is 5 times 6? 30. And what is 2.5 times 6? Well, 2.5 times 6, let's do it over here. 15, move it over 1, move it over 1. Okay, it is 15. So in real life, the dimensions are 30 by 15. Okay. Let's pretend I actually have this. Ooh, I should have flipped it the other way, but that's okay. So in real life, the huge thing is actually 30 by 15. Now, I want to shrink that down by a scale factor of 5. So how do I do that? Remember what I learned from the last lesson? If I want to go from small to big, I multiply by the scale factor. But if I want to go from big to small, I can divide by the scale factor. So I'm going to divide both of these by 5, my new scale factor. Okay? And if I do that, I actually get 3 and, oh gosh, what is this? 6? No. Yes, duh, 6. Okay. So now my new swimming pool, let me go and erase my giant one that I just drew. Too big. Took up all my space. My new scale drawing is going to be 3 by 6. You see how I flipped it so that it matched the same triangle, rectangle up here? Okay. This is my new swimming pool. It's still to scale. That's what's so funny, is we still kept it to scale because the new scale is 5 meters to 1 centimeter. How did we do that? Well, first we changed it to the actual using this scale factor that they gave us. And then I divided it by 5 to shrink it back down into my new scale factor, okay? We'll answer some questions about that over here. Now, you could have taken these nice little number line looking things like we did at the last lesson and said, okay, I know the scale factor is 1 to 6, and then you can just split it from there. What's half of that? 3. What's 3 more than that? 9, 12, 15, 18. So you could just gone up like that, and then you could change it down here to your new. So this is the actual with the new scale, okay? So you could model it that way, or you could just do it the math way that we did over here. You can reason about how the scales in each drawing are related. The original scale, which was 6:1, the new drawing scale is 5:1. So the scale from the original drawing to the new drawings is 6:5. So what they're doing is they're taking the original scale drawing to the new scale drawing would be 6:5, okay? So if I was comparing this drawing, the original one that the architect did, and then mine, I would say the scale would be 6:5. Okay, let's go ahead and connect it. What are the dimensions of the pool in the new drawing? So the one I just did, the dimensions are 6 to 3. Let me go ahead and turn my paper real quick. I've got my sticky notes everywhere like normally. Okay. Boop. What are the dimensions of the new pool drawing? They are 6 centimeters by 3 centimeters. How are the two double number lines related over here on the model it? The two double number lines are related because if you look, they actually are representing the exact same thing. Like we're still representing the same actual pool, correct? And you can see that there are some numbers that don't change. Like for instance, the 30 and the 30 are the same. The 15 and the 15 are the same. Okay, the 1 and the 1 are the same. So how we can say that in words? Well, let's think. The first double number line shows how to use the dimensions of the original drawing and the original scale to find the actual. And then the other number line shows the dimensions of the new scale to the new drawing. Okay, so basically all we're doing is explaining what this is and what this is. The first number line is to the original drawing to the actual pool. Sorry guys, I got confused with what I was writing there for a second. Original drawing to the actual pool. The second number line is the actual dimensions to the new scale. Sorry, my handwriting is so sloppy. I'm trying to record these quickly and write in cursive. It's so hard on this pen. So bear with my sloppy handwriting, I'm sorry. I will try to read the words out loud as I'm saying them. That way you're not like, wait, what the heck is that? Okay, number 3, analyze it. How do the dimensions of the pool in the original drawing compare to those in your new drawing? So how are these dimensions different than my dimensions? Okay, basically what they're asking is how are they related? Well, they're represented differently. So in the original drawing, 1 centimeter is represented with 6 meters. And in the new drawing, 1 centimeter is represented by 5 meters. So for every 5 centimeters of length in the original one, there's actually 6 centimeters in the new one. Okay, so basically all I'm going to do is just write the new scale factor. If I want a scale factor from the original, gosh, once again, I just lose what I'm doing in my brain. Original, O-R-I-G-I-N-A-L. Okay, so original drawing scale factor was 5, okay? I'm just going to say 5. Oh no, sorry, the original was 6. The new one that we did was 5, right? Yeah, okay. So original drawing 6, new drawing was 5. So what we can say is if we compare the two, we can say it's 6 to 5. The new drawing is a scale drawing of both the actual pool and the original drawing. Why? Well, it's because we had to go from the original drawing to the actual and then to our new one, right? So that's why. Why is it that? It's because we started by going from the original drawing the actual pool, then back to a small drawing that is our drawing. Think about all the different models and strategies we just discussed today. Basically, we talked about this number line system again, but we also talked about how we can do it mathematically by multiplying or dividing, depending on if we're going big to small, small to big. Which one helped you better understand how to solve it? For me, I would say the math helped me this time. Like where yesterday's lesson, I definitely think that the number lines helped me, whereas this time I believe that the multiplying and the dividing helped me the best. So explain what you like, pause the video, fill that out. We're going to go ahead and move on to number 6. Okay. Number 6. The drawing at the right is a plan for an apartment. The length of each square on the grid is 1 centimeter. Okay, it represents 1 centimeter. So this is kind of like our drawings that we did in our class. So 1 square is the same as, oh, I should make a little 2. 2, it's a nice little unit ratio. 1 centimeter in real life, okay? The scale from the apartment to the drawing is actually 8 feet to 1 centimeter. Draw another scale drawing of the apartment using a scale from the apartment to the scale drawing of 1 foot to 4 centimeters. And justify why your drawing is accurate. Okay, so let's go ahead and break this down. There's a lot of information here. I'm going to highlight some important stuff. The drawing at the right is a plan for an apartment. The length of each square on the grid represents 1 centimeter. Okay, so each of these squares is 1 centimeter. The scale from the apartment to the drawing is 8 to 1. Okay, so for every one of these centimeters, it's actually going to be 8 feet in real life. Now I want you to make a different model or, drawing on this same grid paper. And I want you to use a scale that says 4 feet is 1 centimeter. Okay? Okay. So let's go ahead and think about this. For every one of these, we have 1, 2, 3. That's 3 centimeters. In real life, we would multiply that by 8 and get 24. So that's actually 24 feet, right? This is 1, 2, but 2 times 8 is 16, so that'd be 16 feet. This would be 16 feet because it's also 2. This is 2, so it's 16 feet. This is 1, 2, 3, 4, 5. 5 times 8 is 40. This is 1, 2, 3, 4. 4 times 8 is 32. Okay, so what I just did right now is I just now found the dimensions of this apartment in real life. I'm going to erase this one right here so I don't get confused. It's not 3, it's actually 24. Let me rewrite it closer. 24. So this is what it is in real life, okay? It's 24 by 16 by 16 by 16 by 40 by 32. Now, knowing that, pretend this is real life and that's one big apartment. How do I go from big to small? I go from big to small by dividing. Okay? My new scale factor is 4 to 1. Take my big apartment building and divide each of the lengths, divide them by 4. Okay? I'm going to do it in a different color so that we can tell the difference. So 24 divided by 4 is 6. So the new length of that side would be 6, okay? Because we have a new scale factor, it's 4. 32 divided by 4 is 8. 40 divided by 4 is 10. 16 divided by 4 is 4. 16 divided by 4 divided by 4. So this would be a 4, this would be a 4. Now let's go redraw it with my new dimensions. And my new dimensions are in red, okay? So my new drawing is going to be the red one. Let's see, I'm going to start on this side. The new dimension is 6. So let's go 6. I'm just going to start right somewhere over here. 1, 2, 3, 4, 5, 6. Okay? And then we're going to go over 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And then it goes down 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ooh, they should line up. Let's try that again. This should be 6. 1, 2, 3, 4, 5, 6. Ooh, I'm glad that I caught that. I missed one right there. And then this should be 8. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. Okay. I'm not going to justify why my scale drawing is correct. Basically, they are proportional. Would you agree? Like, yes, one is smaller than the other, but remember like the me jumping into a shrinking person device? I wouldn't have like tiny arms and one long leg. I wouldn't change shape. I would look the same, just be smaller. So they are proportional, and I changed it from having a unit ratio of 8 to 1. I changed it to 4 to 1. Now my steps of doing that were, first I had to make it into the actual, right? By multiplying everything by 8. And then I divided everything by 4 to shrink it back down. Okay, don't forget the steps. If you want to go from small to big, you multiply. If you want to go from big to small, you divide. And sometimes you have to do both, like we did here. We had to go from small to big, from big to this one. Okay, number 7. The image at the right is a Foursquare court from a scale plan of a park. Okay, so they want to make a Foursquare court. I know people still played Foursquare. The scale from the actual court to the drawing is 8 to 1. Yay, I love it when they give it a unit ratio where we don't have to worry about anything. Oh, 8 to 1, beautiful. Draw another scale drawing of the court. Okay, and the new scale drawing is going to be 12 to 1. So this is going to be exactly like the apartment problem. We're going to start with this one. We're going to change it to the actual by multiplying by their original scale factor, which is 8. Then we're going to shrink it back down, and we're going to use it by 12, okay? So let's just pretend we're changing this to the actual. We times this by 8. We times this by 8, because remember we're going from small to big. We multiply. So 8 times 3 is 21. Oh, sorry. 8 times 3 is not 21, 24. Yes? Sorry guys, I'm reading the book for a second. Okay, so first we changed everything to giant, right? Okay. So now we've got 24 and 24. Sorry, I was just checking my work. Okay, 24 by 24 is the actual. So if we go outside, the whole court is 24 feet by 24 feet. Holy smokes, you guys, that is a big Foursquare court. It's probably not for Foursquare, like with the kickball and you like throw the ball into each other's square, because that's huge. Okay, so in real life, it's 24 feet by 24 feet. Now it says, let's redraw a new one that shrinks it back down to paper size, but for every 12 feet, it's 1 centimeter. So to shrink it back down, I've got to divide by 12. Now what's 24 divided by 12? That divides nicely into 2. So my new little court, ooh, I'm going to even make it smaller. It's going to look like this. It's going to be 2 centimeters by 2 centimeters. Okay, I'm not going to justify why my drawing is accurate. I can say it's accurate because it's still proportional. It's still proportional to the original drawing. All I did was reshrink it down with a new scale factor. So let's talk about what we did one more time. We took the small drawing, we blew it up by multiplying to what the actual would look like, and then I shrunk it with new dimensions by using our new scale factor of 12 to 1 by dividing. Okay, is this our last problem? Hooray, it is. Number 8. A design for a playground includes a sandbox. The length of a square on the grid represents 1 inch, okay? So let's see if this is 1, 2, 3, 4, 5. So if those are 5, that would be 5 inches, okay? Right there. So if that's 5, we know this is also 5 because it's a square. Okay. The scale from the playground to the drawing is 12 to 1. That's great. I love it when they give us unit rates. Got a 1 in there. So that means for every 1 inch on this little drawing, oops, that was a weird looking arrow. For every 1 inch on this little drawing, it's actually 12 inches in real life. Now draw me a new scale drawing of the sandbox using a scale from the playground to the new drawing of 20 to 1. Okay, same thing we've been doing this whole time. First, we are going to blow it up to a real life, then we're going to shrink it back down with the new scale, okay? So by blowing it up, I'm going from small to big, so I need to multiply. I'm going to multiply by 12 because that's the scale factor. I know 5 times 12 is 60. I think of a clock. So in real life, this thing is actually 60 by 60, okay? So now I'm going to take my actual and now shrink it back down with a scale factor of 20, okay? So now I'm going to divide by 20. Divide by 20. 60 divided by 20 is 30, which means if I were to redraw this, wait, 60 divided by 20 is 30. No, that'd be huge. Sorry. 3. 60 divided by 20 is 3. So if I were to redraw this, let me erase some of my doodlies in here because I gotta redraw now. My new drawing would look like this. It'd go 3 by 3. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, 3, 3. And my new scale factor is 20 to 1. Now let's, that was a weird N. Let's review what we did here. We took the original drawing. We blew it up to the actual by multiplying. Then I took the actual and divided by the new scale drawing because if I'm dividing, it means I want it to get small again, right? Okay. And I'm not going to justify why my drawing is accurate because look, they're both proportional. If I would have drawn a rectangle, then I'd have to say something different and be like, well, they're not really proportional, so what did I do wrong? But they're both proportional. All right, guys, we will do these pages together in class. See you then.